So, here's the story so far. Last year, I started a series about JavaScript infrastructure. And so what happened is that I wrote this blog post about how to build a JavaScript bundler. And then I kind of just didn't have time to finish it. It was like 95% done, like literally all the way done, except for a few finishing touches. And so what happened is that I just had other things to do, and now I'm back. One other thing to keep in mind is I had a wisdom tooth taken out literally like 10 days ago, and I'm still a little bit in pain, so I'm a little bit on painkillers here, so maybe this is not the best idea, but I'll try my very best. Also, shout out goes to Japan and the government of Minato Ward in Tokyo, because they have this awesome childcare benefit where we don't always get a slot, but sometimes on Saturdays we do get a slot where we can drop off our daughter at this childcare facility, and she'll be taken care of. She'll have a great time. She gets to practice her Japanese as well, because she's mostly in an English-speaking environment, and like for most of her time during the week. But the great news is that it's very cheap. It's like 500 yen for an hour, which I think with current conversion prices in the US, it's like less than $4 for an hour, which is crazy. That's amazing. So very appreciative, and that allows me to spend a little bit of time here today to kind of do this whole thing live, because I just want to, last time when I did it for the JavaScript testing framework, I just recorded myself. I did one take and that's it. And then I think I can also just do it live and then see how that goes. This is the first time I'm doing this. First time I'm using software to do streaming. We'll see if it works. I'll do my best. I have some keys here. Okay, cool. I can switch around. So maybe let's just get started. So this is a blog post that's going to come out pretty soon, called Building a JavaScript Bundler. If you're watching, you can also just spoof the URL here and key that into your browser, and that should work for you. But basically, last time we were building a JavaScript testing framework, and I showed all of these cool packages that are part of Jest, because it consists of 50 packages, and then we kind of just started building a testing framework from scratch using all of these packages, right? So if you haven't seen that one, highly recommend checking it out, because a bunch of these things I'll try to call back to them if I can, but some of them make more sense if you're familiar with that blog post. All right, let's see if that works. All right, so this is my camera. This is the other one. Okay, cool. So, is this working? Yeah, it's working. Cool. So this is the blog post, and as I said, there's this one about a JavaScript testing framework, and today we're going to build a JavaScript bundler. And all that I have so far is an empty folder with a Git repo in it, called Jest Bundler. So the point that I'm making here is I don't actually think this is a viable idea at this point in time. I think 5 years ago we could have taken parts of Jest, made it a bundler, and turned it into kind of a more holistic tool chain rather than just being a testing framework. But that's not really what happened. There was very little interest in it. At the same time, those core packages of Jest, they are really valuable. And then when we were working on Metro, the JavaScript bundler that Facebook is, or Meta nowadays, I guess, is using for React Native, that one was using a lot of the same concepts that Jest was using, in terms of it had to do this kind of haste module resolution, which we went into in the other blog post, had to do that really fast. It had to do stuff in worker processes, so it was using Jest worker. So initially Metro and Jest were completely divergent technologies that kind of used the same, were relying on the same concepts. But when I was back at Facebook managing JavaScript infrastructure, I was trying to work with the team to take a bunch of these packages from Jest and then put them into Metro. And then if you look at the Metro source and you type in Jest, let's see if we find a bunch of package JSON files that have references to Jest packages. Yeah, so jest-haste-map and Jest worker, jest-haste-map, Jest validate. So there's a bunch of Jest packages that are part of Metro, right? And so arguably, we could have kept working on Metro in a way that we replace more and more parts of it with packages that are in Jest, or turn Jest into much more of a holistic toolchain. We didn't do that. it's still possible, and I'm going to walk you through how to do that with jest packages today, because I think they're just a good basis for like building a bundler. Not saying that, you know, necessarily that's like the best way of going about it, right? So the 5 steps that we're going to look through is searching files on a file system, resolving the dependency graph, serializing the bundle, executing it using a runtime, and then compiling each file in parallel. And you know, if we think of JavaScript testing as a map reduce operation that maps over all the test files and then reduces them to test results, then JavaScript bundling is more like, you know, mapping over all source files and then reducing them into a bundle. And so let's try if we can do this in 1 hour or less. In this blog post, there will be like one line of so one code example that just sets up our configuration. I guess I did all of these already. So I'm just going to copy paste these. And basically, we're just going to create like a bunch of product code, right? In this case, it's just a bunch of fruits. Create an index file and then add like a bunch of base packages that we're going to play with. So I'm going to just run this. I've since actually switched from Yarn to PNPM. PNPM is awesome, but this example is still going to use Yarn, similar to the previous blog post. All right, everything is working. Cool. So I get started here, and then what we can do, I'll switch to VS Code for the most part. We don't need this. We'll open VS Code. Okay, and then we have an index file, and then here's the code that I just ran in the terminal that's like just creating a bunch of like JavaScript files that require other JavaScript files, and then we have like a package.json file that like adds a few packages like chalk for like printing colors. It adds jest-haste-map because we'll use that again, and then also yargs, which is for parsing command line options. And so what we have now is we have like our product code, and hypothetically we have an entry point here, and we run that in Node. It just prints out apple, banana, kiwi, melon, tomato, kiwi, melon, tomato, which is basically just stringing together. If you look at entry point here, it requires apple. Apple requires like prints or like exports apple, then requires banana and kiwi, and then it goes through that. There are no cycles in there as far as I remember, so that makes things a little bit easier. But let's get started. So the first thing that we talked about earlier in the blog post was we should figure out how we efficiently, you know, look for all the files on a file system. Most of the time nowadays, you don't really need to do that anymore. You kind of just start from an entry point and then incrementally bundle. But in this case, you know, we're building something small. And also, you know, if we are using jest-haste-map, we can actually make that very scalable to like, you know, literally like millions of lines of source code and like, you know, tens of thousands of files. So this approach will definitely work for very, very large repos. But there are ways where you can do that without doing all the work ahead of time. But for our example, we'll do that. There's also, if you do all the work ahead of time, you can theoretically think about, you know, if you have like a really big repository, you have like CI integrated that runs on every commit on master that, you know, generates like artifacts and information about the repository, about each file, about dependencies, stores those artifacts somewhere on a remote cache, and then when you locally like bundle, you just pull that down and like rely on that information. So the reason why I like things like jest-haste-map is because it actually allows you to do that and then scale to like, you know, gigantic repositories, but it also works really fast for like just a few files, and like it gives you kind of the same kind of abstraction to work with. Either approach would be fine. You know, we could like not do any crawling in the beginning and just work from like the entry point that we're given and incrementally discover information. But in this case, we're just gonna get information about everything and then see how that works. So we're using an MJS file, which is using ES modules in Node.js. And the first thing that we need to do is, I also have, you know, since last year I got the GitHub Copilot installed, which is like writing all of the code here. So I'm basically just pretending to write code. So anyway, so we need jest-haste-map. There's a bunch more stuff that we need. First, we need to figure out what is the root of our file of our product code base, and like with common JS modules, that would be very easy. You just do like dir name and then product or something like that. That doesn't really work anymore as easily with ES modules. But let's get the way it works. I think we need those two, and then also this is very confusing. I think I got that from like Stack Overflow or somewhere. So we get the root like this. We join the dir name of file URL to path of import.meta.url. So that is the path to the index.mjs, then turns that URL into a path. And then this gives us the dir name, which is basically just, in my case, it's like users, my name, projects, interesting Copilot suggestion, just bundler, something like this. Okay, and then it joins that with product, so that's the URL. Okay, so get the root of our product code. Okay, and then what we need is we want to create a haste map. There's still this issue where we have to we have to do new jest-haste-map.default. I think jest 28 is coming out soon finally, which I think should get rid of this problem. If you're using TypeScript, TypeScript will be able to figure this out on its own. But if you're using ES modules, for some reason, there's still this kind of legacy artifact there. So anyway, we're gonna only look for JavaScript extensions. We're gonna call it just bundler. That's for caching purposes. And then there's like something we want to just wipe that out. That's like a legacy option. Don't really need it. That's only a React Native concept. It's not legacy, it's a React Native concept, but for our purposes, we don't need it. And then we have root, and then for some reason, we have to specify it like this. This might not be necessary, and it might just like automatically do it, but I've done this in the past. And then we also want to make sure it uses all the available CPUs on the machine to parallelize the work. So yeah, exactly. Thank you, Copilot. Very good. Okay, and then let's get the list of files. So we have haste.fs and the module map, haste map build. Oh, amazing. Copilot actually really knows what I need to do. And then we can do haste.fs.get all files, and then let's run our code. I should increase the font size here a little bit. Let me get this figured out. Okay, that should be good. Let's run node index.mjs, and that did not work. Cannot read properties. Oh, this is supposed to be called extensions. Oh, platforms. I don't know. Okay, I'm missing a bunch of S. Okay. Oh yeah. So this is interesting. Copilot actually told me the wrong thing. I have to await here. Thanks to top level await. Cool. And now we get a list of all the files in our product folder, right? And so that's a good start. Bundlers usually require a lot of configuration, right? And so what I want to do is I want to make it so that you do index.mjs entry point, and then yeah, I think this is exactly what I want to do. Give it an entry point and then start bundling from there, right? So let's import yarks. Oops, and then okay. Let's do that on them. Let's get rid of this. We don't need it. And then get the options. So what is it? Is it options equals yarks process.argv, I think. And then we need the entry point. That would be options dot entry point. And then let's make sure we also print some good error messages. If it doesn't exist, then we'll throw a new error. Entry point does not exist. Please provide a path to a valid file. All right, cool. That works. And then let's also import chalk. That allows us to print like some nice things. building. Oh. That's just telling us we're building that file. Oops. What's happening? Okay. I usually put in like a nice little arrow in these kind of things. So let me just copy that from the actual blog post. All right, and then when I'm running this, it says building product entry point. Okay, cool. That is exactly what I wanted to do. Perfect. So it does exist. Let's just do the opposite here. Perfect. This is all working. Okay, so now we actually call our bundler, tell it start bundling from this module called entry point. So that would be your index.js or your app.js or whatever it is that like starts like doing things in your code. Okay. And so we got that, and the next step is we need to resolve the dependency graph. The great thing is that Haste-fs already got keeps track of like dependencies. So that's like really the best thing about the jest-haste-map thing. In the last blog post, we only used it to kind of get a list of files similar to here, so we know what's kind of going on. And I was kind of saying in the video last time as well that there is a lot more stuff and a lot more data and info that it keeps track of. And so one of them is actually that it like can give you dependencies for each individual file. So for example, we can do hastefs.get dependencies for the entry point, and then we can console.log that, and then it should tell us that it's Apple. Yes, perfect. The problem is that this is like a relative path, and we need to kind of resolve that to an absolute path. And that's something that we can do with a dependency resolver, right? So I guess what I want to add here is there are packages part of Jest that help you resolve dependencies. So the problem is that in this case, yeah, it says that it's like a relative path to Apple, but then what if you have a module like, let's say here, it like requires like a package name like chalk, right? Like we had that just earlier, or yargs. The problem is we need to implement the full node module resolution algorithm to know what these strings instead of require statements like actually refer to. And the cool thing is that Haste-fs kind of automatically extracts all these dependencies, so we know if we look at this recursively, like what are the files that we need to look at. But then if we cannot resolve them, then we need to build the node module resolution algorithm. The point I'm trying to make is that Jest actually has packages to deal with that. So there's one called, they're like two packages because they're doing different things, jest-resolve and jest-resolve-dependencies. So we'll add them to our project. So once that's done, let me just add the import. So there's import the resolver from jest-resolve, and then import the dependency resolver from jest-resolve-dependencies. Okay, let's see how we're going to make use of those. So we can remove this again. And so first off, we need to create an instance of our resolver. Again, it has the same kind of issue here with resolver.default. Interestingly, Copilot is giving me the wrong thing. So first off here, we're passing the module map. We're getting that one from the haste-map build. And the module map is actually what keeps track of all of these kind of cross references of like this file depends on these files, and like it keeps track of some other like information as well. So we pass it the module map and then a bunch of options. So again here, extensions. There's a small inconsistency here in that it like wants the extension with a dot in the beginning. Definitely something that should be cleaned up, because here it's without the dot and here it is with the dot. Definitely not very good. We pass it the option that it doesn't have core modules. So let's say you have like, let's say require path. That is like a module that is a core Node.js module. So that would not exist in our product code, in our front end. That only exists if we run inside of Node.js. So we're going to tell this resolver, hey, if you come across something like this, don't look at it, or, assume that this doesn't exist. So you should actually throw and that's better than, trying to resolve those modules that don't exist in our product. And then I think we have to give it a root directory as well. Okay, cool. So we got that, and now we can create a dependency resolver, and that is a dependency resolver that then takes the resolver and the haste-fs. So there's like some composition going on here. This looks maybe a bit confusing within Jest. Like this does make a lot of sense because the resolver only needs information from here. The dependency resolver is the one that actually, and that one can like work on like a virtual kind of like file system. And then this dependency resolver fully implements a node resolution algorithm, makes use of the optimized haste-fs to like figure out what the dependencies are. And so basically what we did earlier, we just asked haste-fs for the dependencies, and now we ask the dependency resolver to resolve our entry point. Okay, and now if we run this, cool. Now we get like the full path to our Apple.js. Let me see. Is everything still working? I think it is. Cool. Let's go back to coding. Oops, don't need this. All right, so now we have, we resolve from the entry point to Apple.js. Oops. Apple.js. Sometimes this autocomplete is very weird, and it has this, what did it do here? That's really weird. Okay, to Apple.js. And now what we need to do is we need to resolve from Apple.js to whatever that's requiring. In this case, banana and kiwi. Banana.js and kiwi.js. Okay, and so the way I want to do this is by using a queue. So we'll start a queue. We'll start that queue with the entry point. And then while that queue is not empty, we'll process each module that's in that list. So first off, we do queue.shift. The reason I could do recursion here, but the reason why I want to use a queue is because, you know, dependency trees could be arbitrarily deep. If you use recursion in this example, then at some point your bundler is just going to break because you have some Stack Overflow issue. All right. And then what we do, we push to the queue the result of resolving the dependencies. And then, yeah, we also need to actually keep track of all the outputs, right? So all the files, all files, we can use a set, and then files.add the module, and then we can console.log all files. Okay. What happens now? Perfect. Now it gives us a list of all of the files that are going to be part of our bundle. There's one problem here. Let's say we have, I don't want to actually run this now, but let's say this banana module requires entry point like this. What would happen is we would run in an infinite loop here. Basically because we have a circular dependency, which is very common in actual JavaScript code bases, especially large ones. If you use Metro with React Native, most likely you don't have that issue because Metro actually warns you and is like, hey, you have a bunch of circular dependencies. This is not good for bundling performance. This is not good for a bunch of reasons. So, you know, try not to do that. Most large code bases that I've seen like have this issue. So let's say you have a module A, requires a module B, requires a module C, requires a module A. That's a circular dependency. And so we need to guard for that, right? And the nice thing is we have this all files set already. So yeah, thanks Copilot. We can do that. If this is already part of all files, then we'll just continue. We have already processed that file. We don't need to double process that file and its dependencies. Sweet. So now we have a list of all of the files. And so what we could do is, let me copy my message here and then say, found all files.size files, and then let's just log them. Okay, we got them, found 6 files. Sweet. All right, so we have this, and now the next thing we could do is we can like serialize the bundle. And so let's try to think about what we want to do in a bundler, right? I was talking about how it's a map reduce operation, and initially we just want to find all of the files and then we want to map over them. That's like usually like a code transformation step. We'll get to that later. But at the end of the bundling process, we have to reduce all of those files into a single file. And like that step is like, as far as I'm referring to it as like called serialization. That's what we call it in Metro. But basically we take this like array of files and the contents of those files, and then we put them together into a single file, and like that's going to be our bundle, and like we put that on our CDN and then we run it inside of a browser. So let's start off with like a naive approach here, right? So we just get the FS module from Node, so we can read files, and then what we can do is we'll serialize the bundle. So let's print it here, serializing bundle. Okay, we get rid of this log, and then let's put all the code together, const all code, and then we can do this async. From all files, map async file. Okay, and then we need to get the code. Oh, interesting. This doesn't exist on HasteFS, but that's fine. Await.fs.promises.read file, udif8, and then all code.push code. All right, and now we got all the code. And then if we want to, we could just concatenate them. And now we have serialized our bundle. So let's see what our bundler does. All right, so this would be our JavaScript bundle. We just basically print out each file. Those are serialized, we concatenate modules. But that doesn't really work. So the problem is that we can never run this code because everything is just in the same scope. There's no require function anywhere. It's in the wrong order of execution. Like this just like doesn't work. But that's like the naive approach of like serializing. So there's one thing we could do. We could build a bundler that does inlining. And I actually want to do that because I think it's really fun. So this is a very simple kind of file, a very simple project where every module kind of just exports one thing and then like requires something, right? So maybe we can just build a bundler that inlines all the code and then can actually run. So let's see. How are we gonna change that? I need to like kind of page back in some of the memory that I had about this. Yeah, okay. We get rid of this thing in the bottom because we don't need it anymore. And then what we want to do is we actually want to extract information about each module, right? So let's get rid of this. Let's turn this into, let's call this scene. We have seen those. And then we make a map of modules. Okay. So this is like similar to how Metro works. It actually makes like a module map when it goes through all the files as it discovers dependencies. We're probably not going to need this dependency resolver. All right. So this is all good. We want to add it to scene modules. Okay. And then we don't need this part of the queue anymore because we need to get like a different dependency map. Okay, so the problem with what I'm trying to solve is when we want to inline modules, then we care about those names. So let me try to wrap my head around it. Okay, so first off, let's get the code. We'll just read file sync the code from each file. It's much easier in like this example to do that. Okay, and then we'll also need to get a dependency map. Dependency map means each module has like certain modules that it refers to. And so let's try to get that done. So we'll do hastefs.getDependencies for this module, and then map the dependency name. Yep, and then we'll return that. And then also resolve. Okay, so ideally, this is now a map, like with like string and then array string, and it might look like something like this. So for entry point, it might look like this. It's a map where the entry point is like, oh wait. Sorry. For each module, we have like this map. So entry point has like this map. Okay. And then entry point has one dependency called apple, and it like is literally this string. So what it will look like is one entry looks like this, and then path to apple.js. And then if you look at apple, it would have an entry banana, like ./banana, that refers to the full path of the banana file, and then the same for like ./kiwi refers to the whole kiwi file. So that is important because we want to know, like what we were doing previously with this dependency resolver. We can change that now, dependency map.values. We just need the values here to the full paths. That means we don't need the dependency resolver anymore. Let me remove that from our project. So what we're doing now is we have this earlier we were just like resolving from each module each of the dependency, but then we had no connection between the require statement and like what was written into that require statement here to map it to the module that is being required. And like we need to, if we're doing an inlining compiler, we need to exactly know how these two are referring to each other. And later on, actually, we do need to know that information as well. And just dependency resolver doesn't actually have that information. So now we have that dependency map, we have that code. So let's call it metadata. It's the code, and then also the dependency map. All right, and then we'll do modules.set module and metadata. Okay, perfect. And so what we need to do is we want to find the module body. Okay, so because I want to inline all the code, we're not gonna have any problems here because there's nothing that this module exports. But then for every other module, let's say this one, we want to get the module body. In this case, it would be just that string that we assign to module that exports. So let's try to use regex. Okay, so code should be either the module body or code if we don't find it. So we need to write a regex here. Okay, and then the default case will be that, and then usually when we do regex, we want some element from here. Let's say the 0th, but it's probably not that. Okay. Yeah, it's probably gonna be the first one. All right, so we're gonna match for module that exports, and then a white space here, and then some stuff here. And then I'm assuming we'll have a semicolon here. Okay. So let me just see if what I'm doing here makes any sense to anyone. Let's, wait, that doesn't work, does it? Oops. Yeah, okay. I need to get rid of this. Oh. Somehow I'm missing all the plural words. And there's a typo here. Wow. Not on the top of my game today. I got rid of all files. This is scene.size. Okay, cool. All right. I got this together. Perfect. All right. So let's see if it works. So basically all I was trying to do here is get the dependency map for each module and then get rid of the module that exports from modules that have that. And so why is that interesting? Is because now the serialization step becomes completely different. Let me just see if anybody's still here. Maybe not. We'll see. So now the serialization step becomes like completely different. What we want to do is, so first off, earlier when I was showing how we were collecting the information and just concatenating it, we had the entry point on the top. But usually for a bundle, what you have to do is you have to execute every other module before you can run the entry point. So we're gonna have to process everything in reverse now. So for const module and metadata of modules.reverse. Wait, that doesn't work. We need to array dot from and then reverse because reverse doesn't exist on map. Okay, so we look at each module in the reverse order of how we discovered it. That means that the entry point will always run last or be at the bottom of our bundle. And then we'll get the code from our metadata, and then at the end we'll just rewrite that code. Okay, we'll rewrite that. So basically that's kind of like processing our code, and then we'll do entry point dot code. Okay, so if you run this, nothing will happen. It will basically just print us out the code from our entry point. And so we're trying to do an inlining kind of bundler compiler here. So how do we process the code here? And the cool thing is, because we're processing modules in reverse, we'll just pick the code from each module and then put it into the next module in the location where its dependencies are. So the way we do that is we look at all the dependencies. So for const dependency name and dependency path of metadata dependency map, cool, thanks Copilot, we're gonna inline the code. That is beautiful and not entirely correct, I think. Yeah, it's not. Very interesting. Copilot is like giving me some stuff, but it's not entirely correct. Okay. So what we want to do is we want to replace the code. We have to put together a regex. That's going to be a bit fun, and then replace it with the code of the module that we're going to inline. Okay. And so now the question is, what is the regex going to look like? So what we want to do is we have apple plus require banana. And then the banana is like banana.banana or something like that. And so we want to put that in here. All right, so what we need to find is the require. So we want the require, and then this is almost correct, but it's not really. Okay, so we need to have either single or double quotes, right? So it's either this one or the other one, and then we have to refer back to that, and then dependency name. And then here we refer back to it like this. And then we have, okay, cool. So the problem is here, dependency name might have like backslashes in it, right? So if we run it, this will be part of the regex. So we need to escape those path elements. This is like stressful, writing regex right here. We don't need that. So we need to either find a dot or a slash and then replace it with is it like this? Full expression. Wait, I have a syntax error now. I'm very confused. Oh, okay, the regex is not terminating. So let me see. This should only be one. Also global because oh, okay, this one is missing. Yeah, okay. Phew, I think that might have worked. Let's see if this worked. regex is always very confusing. So we have either single or double quotes, and then we escape those characters and then have a back reference. Okay. Okay, module. Again, the plural, for some reason. Oh yeah, oh man, it works. Okay, this is amazing. Okay, so now we actually have a bundler. So we can run this code in Node, and this is like an inlining bundler. Okay, it will actually run exactly what we want it to run. It takes all of the module code from each module and then plugs it into where that is being used, and then brings that all the way up to the entry point and like kind of duplicates and like kind of gets bigger and bigger in terms of like the strings that it concatenates. The final thing we could do here is so wait, they all like yeah, okay, so whenever we see this, let's just do this. This is fun. Okay, so it's more regex. So whenever we see this plus any white space and another one of those, then we'll just replace it with nothing globally. Let's see if that works. Oh, perfect. Okay, now we, okay, so we had an inlining bundler where it was just like inlining everything, and now we have a optimizing compiler basically. So they're like, in terms of the product code that we have, this code means that it's like the optimal code. There's no other way you could represent this program. Well, theoretically you could compress the strings here because they're repetitive, right? So if you look here at kiwi, melon, tomato, that comes up twice. So you could like, argue that maybe this is too long, but then if you put it into variables, so for all intents and purposes, this is like an optimizing compiler. This is in a way the most simplified possible version that I can show you of like what rollup.js basically does, more or less, right? At the same time, I realize everything we did here is like gonna break down immediately, right? Because you can only, you cannot have any other things happening in your modules. You can only do module.exports equals like this. Very simple requires. If I put anything in here, and finally, I'm using like regex here extensively, which would not work with like any sort of complex syntax. I think this is like a really fun experiment, but it doesn't really work that well. The most interesting thing here is that we put together this dependency map, but it's not like a viable like thing that can be used in any meaningful way. That said, Rollup is an incredibly smart tool. If you spend a lot of time thinking about this problem space, more than like the 30 minutes or so that we have spent here, then you can put a bundler together where you get rid of all of the module boundaries and you just put everything into a single file. You rename all the like variables where like you might have collisions because of they're in the same scope, and then you come up with like an incredibly awesome optimizing compiler for JavaScript. So it's possible, but I think in the time that we have, this solution with regex is the fastest I can get to do this kind of inline compilation. But this is not like really a good way to stop, because we have barely built a bundler. We have just like done some regex and concatenated some file. So I actually want to build like a real bundler with like a runtime. So okay, now the thing is, we looked at a bunch of serialization formats, right? The first one was we just concatenate all the strings, and the second one now is like we're just gonna inline everything, and like that works. The first one obviously didn't work, but what we want is we want to have like a serialization strategy that actually works, that where we can actually do some meaningful coding within our product and then bundle it up, and we can actually guarantee that works. So the problem with the initial format was, I don't have that anymore, but like if I just put it together, the problem with the initial format was like we had like module.exports tomato, for example, and then module.exports melon, and then module.exports kiwi plus require tomato plus require melon. Okay, so that was what we had like earlier, and that obviously didn't work for some reason. I thinks it's CoffeeScript, which is not good. All right, and so that doesn't work, right? So here's another attempt. Let's try this, right? Like the problem here is like everything gets overridden, it doesn't work. So maybe we could do something like this. We define a variable, like this is our serialization strategy, right? We define a variable called module. And then here we set the module to empty. And then we do that every time before we execute a module. And then here what we do is we do const tomato module equals module.exports. And then down here we do melon module. And then what we do for this, const kiwi module equals module.exports. And then what we do here for this one is tomato module and then melon module. Okay, so that, I don't want to save that. So that actually could work, right? If we put the modules together, we serialize it, that would probably work. Okay. But now, what if we do something like this? So this module exports a function that does module.abc, and then here do module.abc, abc is 1, and then for some reason this module does module.abc is 2. So when we do tomato module, we call that function, it will actually be 2 because it will use the, well, actually, good point. I just realized it won't be 2. It will be undefined because here is the last time we're resetting the module. So it depends on when we are calling this function, right? So if we call it here, it will be 2. If we call it up here, it will be 1. If we call it down here, it'll be undefined. So this is like obviously going to break down. And then the other problem we'll have again compared to earlier is that you know, if we have a const a equals 5 and then a const a equals 2 in this module, then here it will like throw us an error because like a was already defined up there. So this approach doesn't work, but it might give us a good idea on how to move forward. So if we look at the previous blog post, let's do that actually. If we look at this, where is it? We have like something with eval. Okay. Where we're just running code. Let me see. We have like a thing where we wrap code with the VM context. Okay, cool. Yeah, so here. Yeah, all right. So here's where we have this really interesting thing. This was the previous blog post where we actually do the same thing, right? Like we do like a fake module variable and then we run the code and then we return module.exports. And when we do this running context, it like kind of creates like a separate like, it like wraps everything and gives us like a special scope. So what if we do this instead? We wrap everything, we pass this a function, something called module. And then we do that for everything. So that makes everything isolated. It means that we have like, well, the question here is like, where do we get those from, right? So let's get back to, let's figure that out later. Oh. All right, so now what we have is each module is isolated in a function. So here you can have like a variable here, you can have a variable a there, and like nothing bad would happen, right? Because these are all like isolated scopes, and like for all intents and purposes, they cannot conflict with each other. You know, assuming that the code here is like valid, there are no syntax errors, they're pretty much isolated from each other. So that's awesome. The problem is when we have this, nothing would happen, nothing would run because we just define like 3 functions and then that's the end of the program. So what we need to do is we need to define the modules, keep track of them, and then be able to execute them. So let's create a function called define. And then here we'll define a tomato. Here we'll define a melon. And then here we'll define a kiwi. All right, and then we need to create a define function. So we give it the name and the module factory, that's what it's usually called. And then we need to have a module map. So let's have modules new map. All right, and then we do modules.set name module factory. So that's cool. Now what we do is when we run this program, we define 3 modules. They're not running yet, but we kind of keep track of them, and I think that's a good start. So the next thing we need to figure out is we need to actually run those modules, right? We need to have the ability to require a module. So first off, let's extend this a little bit. In real module systems, you usually also have a variable called export, so it's not that important for here, and then also a variable called require. So that at least will allow us to, when we invoke this, we can pass these things in, and then we figure out during runtime how we require this, like tomato. Interesting thing here is I call these modules here melon and tomato, but here I'm calling them require ./melon./tomato. That's not good. Let's get rid of those. And that way we kind of have the right references. So now what we want to do is we want to have a require function. So let's do that. So require a module with a specific name. And actually, I'm going to start calling this require.js because we're building a runtime here for our code. I'm not sure what I'm doing. And we'll need that. Okay. Require.js. We'll need that in our module, in our bundler as a runtime later on. So let's just start saving this because we're building something that's actually useful. Very good. There's GitHub Copilot is telling me what to write. This is actually a very good naive approach. Very interesting. Thank you, GitHub Copilot, for coming up with that. So every time we require, we could just run the module factory. I like it. That's like a very quick way of doing it. It wouldn't pass the right arguments in this case, but that's not ideal because when you're using JavaScript modules, when you require them, when you import them, you always have this guarantee that that module will only run a single time. It doesn't have to be that way, but I think that makes the most sense. It doesn't have any overhead, but that's kind of how the system that we settled on in JavaScript and in pretty much all programming languages. In JavaScript, it's just like very much dynamic that we're writing our own runtime for our bundler here that's going to be run in the browser. So we can basically do anything here. We could require modules multiple times. We could wipe them away randomly after a set time. We obviously don't want to do that. So Copilot's suggestion here is good, but a bit naive maybe. So what we want to do is we want to have a module cache actually. So that's where we're going to store the results of each module factory execution. All right. And so the first thing we can do is if the module cache has this module, we'll just return module cache.get name. And so the thing is for module cache, what we want to do is we want to do something like this. Const module exports, and that's usually an object by default. And then we do module cache.set name and module. And then that means what we want to return is actually the exports field, because that's how require works, right? So when you require tomato, you get whatever is on that exports. All right, and then so here also we want to do module.return module.exports. All right, and so now the interesting thing is that normally you would call the module factory here, module factory with the module.exports, and then also with require module, because that's our require function. And so when you do that, what you'll run into is that you'll get into infinite loops. Similar when we were talking about earlier about how when we're crawling the file system and we have to just make sure we visit every file and every tree only one time, that allows us to have circular dependencies. They're not good, they're just a common thing in JavaScript, so you need to support them in a bundler. So the thing here is that's very interesting is if you do it like this, and then you have a circular dependency, you'll get into, so first, earlier we were getting into infinite loops during bundling. Here you would get into infinite loops during runtime. And the reason for that is, let me actually just show you. Let me define a module like circular function module exports require. All right, and then this one does module.exports equals require circular. So this module basically requires itself. Usually these things happen over like multiple modules chains, right? So let's just assume this is requiring itself, but it could be through a chain. So when it enters this code, so here you have like a require module circular. What happens is it goes in here and says, oh, I don't have it in the module cache. Let's create a new module. Let's run the module factory. Then it runs this function. And then it passes require here. It calls require again and comes in. It's like, oh, I don't have this in the cache. Let's create a new module. Let's run this function. And then you have an infinite loop. So here, what you want to do, you actually want to set this module in the cache immediately. And then with that, you know, again, circular dependencies can still create you problems if you synchronously depend on like some values being available from from like two modules in the other module. But what happens here now is that you require circular, it will just give you that object, right? You're not getting what you want. This won't be like a circular dependency, but it breaks that chain. So that's why you need to set it in a module cache immediately. So when you have something that like calls the same, like requires the same module that is still being initialized at that time, it will just give you back whatever is there. That said, the thing is that it will be the wrong value because it will be that initial value that's set here, because it will only be redefined at the end of this module that exports. So the interesting thing here is that basically this ends up being a no-op because it will set it to that value, which was the original value. But it won't crash, so that's a good thing. And you know, people write a lot of clowny code, so you want to guard for that, guard against that. Okay, so we got this. We have like our module factory here. I think this would work. I realized that I wrote module factory here, but we have to actually receive the module factory from our modules list. Okay, and then at the end we need to actually require a module, require module kiwi. All right, so that works. One of the problems here is that we're still using like strings here, first off, and like some bundlers still use strings to define modules. So this is actually how most bundlers work nowadays in production. Like they have some system like this to define modules and run them, right? Like this is like the most basic version of this runtime. If you use strings to refer to modules, that will be slightly slower, use more memory, and blow up the bundle size. You know, it doesn't matter for 98% of websites, but if you're building one of the largest websites in the world, this stuff very much matters. Actually, it does have like a very minor like impact to like runtime. On React Native, I remember we changed from string-based modules to integer-based ones that were like ascending without any holes in the array. That was important in the module map, I guess. And that actually had a major performance impact, 5 or 6 years ago. The other thing is that we don't want to have relative paths or so in our bundle. So let's just change this to numbers. So let's say our entry point module will just always make sure that's 0. So we define module 0, and then melon will be 1, and then tomato will be 2. Wait, we want to require module 1, and then require module 2. And then here we do 1, and then here we do 2. Okay, and then that's basically our entire module system. So the thing on top here is what we want to include at the top of every bundle that we're creating. In real world situations, you would want to probably namespace these things like inside of a function so that you don't leak like these variables, but for now that doesn't really matter. So we're gonna just include that top part in every bundle, and then this bottom part will be generating, and then that should like make our bundler work. So this is our require.js template file, and let's get back to it. So what do we need to do? First off, let's have an ID that's keeping track of each module ID. So add to the metadata an ID. And then we have to, I guess, produce the same output that we had earlier when we serialize each bundle. Okay, so let's create a function that's called wrap module, where we give it the ID and the code. And then it's going to return and define. So this is basically just a template for what we had earlier. Define this, and then we have module, exports, and require, as we had earlier. And then, yeah, maybe that's good. Yeah, let's just do it here. All right. I think that's all right. Yeah. And then we still have that regex here. We don't need this module body stuff anymore. That was all just like playing, all to play for. Okay, and then here, this regex stuff we get rid of as well. We are going to replace those with the dependency ID. So that's actually what's going to change. So we're going to keep the require, but we're going to replace it with the ID that we have. Okay, and then here we will want to wrap module. ID code. Okay, and then the thing I want to change here is, here we're rewriting the metadata for each module. I want to actually change that into an output array. So we'll do output.push. Okay, and then the next thing we want to do is we want to add that require implementation on top of our file. So output.unshift fs.read file sync require.js as utf8, and then output.push. Right, so wait, we have all the modules. All right, so the last thing that we had is we had this actually, let's just log it like this, console.log output.join. And then what I also want to do is I want to add the ability to write that file to a test output file. Perfect. Thank you so much, Copilot. So now we can write the file. So let's just try to bundle our thing now. Okay, output to a file. That works. Let's do node test.js. Nothing happens. Okay, so the reason for that is you'll see now we have our require implementation here, and then we have each of our modules right there. The problem we have now is that we actually never, oh, actually it's also, what's happening here? Am I running into like some very weird JavaScript issue that doesn't make any sense? Oh yeah, okay, I need to get the ID here. Totally does make sense. Okay, so this should work now. Okay, now we have the right numbers replaced in here. So 1, 2, 3, 3, 4, 6, no, up to 5. The problem that we have here is that we are just defining those modules. We're not running them. So at the bottom of our module, what we want to do is we want to push a call to require module for module 0. The nice thing is that we always know that our entry point always has ID 0. Okay, so now we run it. It has a require module on the bottom. So if we do node test.js, module factory is not defined because I have another typo here, of course. Okay, and now our code works. So now our bundler actually does bundling, and we can like start having more arbitrary code in our entry points, right? So we could do console.log, hey, I'm a module, thanks. Man, Copilot is so good. But I can also do kiwi is like, I don't know, console.log, I am a kiwi. And then that will run only one time. Let me see. Cool. So now this is where I can show you. Let's say we get rid of this module cache. I'll just get rid of this line here that returns it. Now we recreate our bundle, we run it. Now it should print I'm a kiwi twice. Perfect. So now what happens is we kind of completely flip modules in JavaScript, you know, like the idea of how modules work on its head, and we're running each module every time we call require we run that module from scratch, right? So if we have the cache here, we run the bundle, it only prints it one time, regardless of how often you require the key module. All right, this is working, cool. So this is most of our bundler. The problem is, let's say I want to change my code. Let's go to Apple. Well, let me just take a break here. Not gonna try to make an advertisement, but need a bit of a drink. It's a good time to take a break. We only have one more thing that I want to do that makes this like a real bundler that's competitive. It's already pretty fast, but it only supports basic JavaScript. So what we want is we want to add Babel, because what happens is that you build a bundler and then people come to you and then they're like, they go like this and they're like import Apple from Apple and then console log Apple, and then you go into the Apple file and then people are like import banana from banana, import kiwi from kiwi, and then you do something like this. And then you go into the banana file, and then this person here is like export default banana. This also shows how our regex approach previously didn't work at all, right? I think maybe here we also want to do export default. Okay, and now you run our bundler. The interesting thing is that our bundler will still like work. The problem is you try to run the module, it doesn't work. Unexpected token export. Nothing here works in this bundle. So what we need to do is we need to compile all of our JavaScript. And in the past we've used Babel exclusively, which we don't really use as much nowadays anymore because there's many other new tools. But we're building a bundler written in JavaScript, so it's also fine to just use a JavaScript tool for that. So what we want to do is we want to be able to compile all of this code first in parallel and with Babel. And so what we're going to add is our beloved module called jest-worker. And then that will allow us to do things in parallel. So first off, let's create a worker. The problem is this has to be a JS file because of ES module limitations still in Node, and jest-worker only working with those. But that's fine. We can do something like this. Wait, this doesn't have to be an async function. We'll need transform sync from at Babel core, and then what we need is we'll do almost not bad. Yeah, we want to compile ES modules to common JS modules, and then here I also want to do code. Okay, so now we have a worker file where we can transform each individual file. And then next, what we want to do is we want to import jest-worker. Oops. Okay, and then here we have to change everything around here a little bit. Okay. First off, we create, well, let's do that on the top, where we're creating instances of things. Const worker equals new worker, require resolve worker. That looks pretty good. This doesn't work though, because we're in a ES module. All right. We need this option always. Okay, so what did we do here with the root? We do, let's just copy this. Okay, that should work. Man, this stuff used to be much simpler previously, before ES modules. It's wild. Okay, and now we have this worker, and now here we can start calling this in a worker process. So what we need to do here, well, no, here we need to actually transform the code. So this should be code equals worker.transform file code, but then that I think returns a promise. Wait, not promise, it's async, so we can do this. But we have a for off, and we want to do this in parallel, right? So what we want to do is const results equals this await promise.all modules.reverse. Wait, array.from modules.reverse, and then we map over it with an async function where we get the module and then ID and code. We don't need this. Okay. Phew. All right. This might actually work. What we need to do is, okay, this is like different now. So we just have, let me just rewrite this. So it's this plus the results. Wait. Yeah, no, that's fine. And then join. Okay. So, and then we'll look and write this. Okay, so I'm just kind of writing code here, but ideally if I'm running this, I'm sure I have another typo here somewhere, it will asynchronously call the transform file function here. You know, if you're not familiar with just worker, we used it extensively in the previous post. The idea of just worker is that you can parallelize all the stuff that you're doing across different CPU processes and then do all that transformation work in parallel. For the example that we have here, where we only have like 7 files, that doesn't matter. If you have a couple thousand files in your project, it matters very much when you use like as much available CPU power as you have, because transformation and compilation is primarily file system bound, depending on which hard drive you have. You have to read a lot of files, usually write a lot of files because of caching, and then also CPU bound, because compilation is like purely CPU bound. So let's see if whatever I wrote here is correct, and if it works again, or if it doesn't. All right, metadata dependency map. Okay, so here's one thing I did wrong. I forgot to take out this one from metadata in the destructuring assignment. One other thing I wanted to do is I need to do worker.end. I just remembered that. That's to make sure that our program actually shuts down, because otherwise just worker will just wait for more calls. All right, output.push. Oh yeah, okay, this is obviously not working anymore. I need to return this. Code.replace is not a function. Oh, okay. That is because I am, yeah, okay. How does this work? It's like this, right? This is the destructuring assignment. JavaScript is fun. Yeah, okay, now it works. Okay, now we have a lot more code here, because that's all the stuff that Babel injects. But now every file that has import or exports or like uses ES modules has changed to use require and various other exports and module.export. So let's see now if our bundle works. When I run node.test, boom, it works. Whew, that's it. I built an actual bundler. What's the time? 11:34. Just a little bit over an hour. So you know, whatever I had in the blog post didn't work out as much as it did. But that is basically the Jest bundler. In, I guess here we can say about 100 lines of code, and then a bunch of 40 more lines, 20 lines of runtime, and then 9 lines in our worker. Obviously, I usually have a lot of new lines in there to structure my code. So in total, we're looking at 110, 120 lines of code by reusing a lot of the Jest packages. What I've been showing today is, it's weird. I wrote a lot of this article, or most of it, last year, and just never got around to recording this video. So that's why doing it through a live stream I think is really good. The problem is that this is somewhat of a traditional bundler if you look at development side of things now, because in development what you want is you want to use native ES modules inside of a browser, and you can incrementally do things. You create an import map that browsers support. So for development this is maybe not the ideal sort of bundler anymore. That said, in production all the bundlers still kind of work with this method, because you don't want to ship 3,000 modules to your CDN that every person that opens your website downloads those, right? Even with HTTP 2 or 3, it's still not as efficient as if you get them all together into a single bundle, or multiple bundles per app, one for each route, or whatever you want to do in terms of bundle splitting. The other thing is that we did this kind of inlining experiment, right? If you have a bundler that does inlining on a certain level and then bundles everything else together, you can do many more optimizations. You can do minification possibly across modules when you inline certain parts. So in production, a bundle like this with a small runtime where you concatenate everything together and optimize it will most likely outperform any sort of native browser bundling capability, because whatever code people are writing, that code needs to be as compact, as small, as optimized as possible for production use cases. So I think in terms of development mode, there's more new technologies available in browsers where this approach is not the most viable. At the same time, production-based bundlers are still making use of these kind of technologies, and this is how you make them fast. In fact, most of what I showed you here is how Metro works. Obviously Metro doesn't use regex. It uses AST transforms and Babel to analyze things. And Metro is really fast. You can make it incredibly fast, even though it's written in JavaScript. So if you would like to build your own bundler, or if you have been following, and you want to extend this, I think there's a bunch of ideas you could do. One is you could add a -- minify flag to run Cursor on the output of the code in parallel, for example. You could add a cache so that whenever you invoke your bundler, it doesn't rerun Babel and the minifier every single time when you're running any code. You could learn about source maps and then figure out how you track the output of Babel with source maps, and output a .map file along with your bundle, so that when you're debugging, when you have an error or something like that, in the Chrome DevTools it can show you the right location in the source files. You could add an HTTP server so that you request localhost something / entry point, and it will bundle that file there. You could then add something use jest-haste-map's watch function to see if a file changes and then rebundle it immediately. You could learn about how to build hot module reloading into that require implementation that we had there, where I showed you can wipe away the module cache, and you basically in total control of what you want to do on the client and how you want bundles to behave. And it's not static. A module is not static unless that's just the convention we arrived at, but you can actually swap out the code that runs there at any point in time if you would like to do that. And yeah, I think the final thing is that you could also rewrite this entire thing in another programming language like Rust, and then see how much faster you can get than with JavaScript. But yeah, we at this point of this series that has been unfortunately taken for a very long time, is we have kind of built a testing framework. We have built a bundler. We could extend this series indefinitely. We could build a linter, a refactoring tool, Pretty Formata, or any tool in the JavaScript space, and they all work on like with the same concepts, right? The way you make them fast is like usually through parallelization, right? Like there's a bunch of smart algorithms in like many of these tools, but like there's so much you can parallelize usually, and so there's no reason why these tools cannot share similar infrastructure. I showed you how to do that with Jest, and I mentioned earlier on that that's maybe not how I would build any of these tools nowadays, maybe 5 or 6 years ago, but it would be great if more tools in the JavaScript infrastructure space were sharing the same infrastructure and then not recreate everything from scratch. They could all be fast by default, share a single configuration instead of having like 100 configuration files, one for each tool. So I really hope that this was enjoyable, and this was something that people could follow. I had a lot of fun today. I'm going to head out for lunch and then children birthday parties later on. All right.